Who's going to be responsible for the energy analysis? Is it something that should be shared amongst the team? Or how and when does it happen, and who's going to do it? Anyone can put their hand up and take that.
So I've often said that, energy analysis is just a tool, right? You need that tool to measure so you can drive towards better. You cannot improve what you cannot measure, right? But it's a team sport. It requires everyone to be involved. The wrong way to do it, in my mind, is kind of the way it was traditionally done, or still is to this day, where you've got the energy modeler in the corner, building a model, churning out a report 300 pages long that nobody understands, goes on the shelf. It looks great. It's clearly very clever, but nobody really engages and invests in it. So kind of what I was pointing out earlier on about the thing with Insight, about just making a simple number and letting people see, if you make the window bigger, the energy is going to go up. And doing that in a open way with a design team, it's infinitely more effective. You get buy-in from the client, and it also opens up the questions. Well, can I trust this model? Well, it depends, right? It depends what your assumptions are. So you start to have that conversation about, well, what are your assumptions? And the more you can make that open and transparent with a client, the more they'll trust it, and therefore the more likely they are to invest in something. It's the age-old thing with investment. People don't invest in. It's not that they don't invest in high risk. They don't invest in risk they can't quantify. So I think somebody needs to lead the charge. Somebody needs to take it on and say either client wants this, or we're going to do it as a value-added thing, or we're going to sell it as an extra service. But the more that individual can make it a team sport, so to speak, the more impact it's going to have on a project. And therefore, there's then shared ownership. Architect owns the decisions around the envelope. Mechanical engineer owns their decisions. And the owner owns the decisions around, are they going to maintain the building? How many hours are they going to operate it? Are they going to turn the set points around? And so once everybody's understanding of that, then everybody owns the model, right? Anthony, guys like to add?
Well, I think just to add that, certainly I think energy modelling just needs to become part of the design process at a much earlier stage. In the School of Architecture, I think it's something that we're trying to bring in, that there's been a lot of reluctance to for many years. And but I think that it's changing now, and I think people are beginning to recognise that this is a tool that everybody needs to be well versed in, and it just needs to be part of the armoury. Those students will go out and will insist on having these tools as part of their design process in practice, and that way we can get you can just start changing the industry at a fundamental level, I think.
I'm interested to know how that will change our influence design process.
Yeah, it's a good question. There's a lot of hesitancy amongst the kind of the pure architects, or to this kind of idea, to any kind of level of quantification, I think. I can see it change it, but it doesn't need to shift it dramatically. It doesn't mean that we need to lose anything else. It's just an extra kind of evidence base that we can work with. The same way you might go to a site and try and understand the local context or the cultural history of it or whatever. This is just another thing that you can respond to, and something that's very important today, I think.
If I can just add, I think the process thing is interesting. You might hear this a good bit as well. We'd often hear it from firms that are using Fenestra, or firms that we're trying to sell Fenestra Pro to, more to the point, that they're like, oh, we're not getting fees. We're not getting the fees for energy analysis. We're not doing it. And our argument is, well, you should be. You know what I mean? Everyone should be. It's as important as... Yeah, exactly. And it's just, like you said, it's a team sport, and it's something that has to be done. And I think, to be fair, I think a lot of firms are coming around, and architects are taking a bit more ownership and a bit more responsibility, that this is their design, this is their envelope, this is their whatever, and it's becoming a little bit more embedded and a little bit more inherent in their processes,
Then, following on from that, what are the other barriers preventing daily use of energy analysis software in both the design, on the architectural end, and the engineering end?
I'm trying to think of the right word. I think a big one is that sort of hesitancy to change what you know. you know, it's like, this is the way we do it. This is the way we've done it for the last 20 years, and we're not going to, change is hard for anyone, and particularly an organization, and particularly when you have to learn BIM or introduce or deploy new software and train people, and take the pain of those first couple of projects. So that sort of resistance to change, I think, is a big one. I don't know, what guys, any from your point of view?
Yeah. I mean, I think there's a reluctance. I suppose there's an ownership over a certain space at the moment, and they see this kind of new focus come in, and people are slow to change. I mean, I think that's it, really. I mean, there's a training issue, I guess. And if students, engineering, architect students, aren't being taught it in school, then it's a cost on firms, particularly smaller firms. It's a big issue, I guess. And the sustainability of it, if you're only training one person up in it. But I think change, reluctance to change, but I think there are new pressures, and that's going to drive it, I think.
Also, sometimes the building owner themselves can be an owner that is developing a building to sell it, and they're not worried about the operational energy, or they're not, it's not a thing. So when you don't have a building owner or a client that's in any way worried about that, it's very hard for the design team to take that on, I suppose, going back to we're not getting fees for that,
Should there be an insistence in legislation now to bring this in as part of planning permission, a planning application, where we know that it covers all the biodiversity end of things, all of that, but there doesn't seem to be an emphasis on proving that, or an analysis of the potential energy usage within the building. Should that be legislated for?
This is definitely your bag, Oliver.
Yeah, certainly, I think so. We need that evidence before we build even one more building. We should have that evidence. It's the construction of a building that will operate, well, hopefully for 60 to 100 years or beyond, it has a huge environmental impact. It shouldn't be underestimated. So any decision we make about that building, be it materiality or anything that will affect the operation of the building, should certainly be modelled, and we should have that knowledge before its permission is given to construct that, I believe.
Yeah, I'd most certainly agree with that. I'm long enough in the to remember the resistance there was to just bringing in the digital model through Revit. I foresee a similar journey in terms of the energy analysis, perhaps in one sense as well. But in my opinion, it should be embedded into undergraduate education as well as postgraduate. To all my students out there, you missed out, luckily enough, probably on that, but your forebears will probably be involved in something like that. What is the difference between performance optimization and performance analysis?
Yeah, so the words, right? And we have a lot of, to develop software, you require a team of mix of experience, like product managers. I've got a background in this stuff, but then, your average software developer doesn't know this stuff. And the number of times we argue, what's the difference between analysis and modeling and simulation and optimization? And you go round and round. And there's even funny differences of how structural engineers define analysis and simulation very differently to how energy mechanical do. So it's interesting. But the short version of it is that, strictly speaking, an analysis is like a point in time or one configuration. It's a breakdown of something. If you look at the dictionary definition, it's the breakdown of something so that you can understand its nature, right? Just analyzing something doesn't make it better. So your energy is 10. Is that good? Is it bad? Could it be better? So analysis doesn't really tell you those things if you just treat it that way. Now, other people would define analysis as very broad. Analysis could include optimization, but when you contrast the two, optimization is the act of then using some form of analysis to seek better. And it can come in a variety of forms. People aspire to having the magic button of make it perfect for me. But, buildings are really, again, at Autodesk, I often joke with our mechanical counterparts. We have these great stories in manufacturing where they're optimizing for strength and weight, right? Like the wing of an aircraft or something like that. And I joke, like, that's easy, right? 2 variables, you can optimize for that. But in a building, you have so many variables to optimize for, and particularly that it's really tricky, and we're not near that magic button place yet. So optimize, making it as best as it can be, is using analysis in some form to make it better. And you can do that to varying degrees of sophistication. You can write scripts, with genetic algorithms to search out the best point on a cost-benefit performance curve. Or you can literally go back to, just this window type is going to save energy over this one. That's better. That's, strictly speaking, that's an optimization, right? So that's how I would broadly characterize it.
Oliver, could I throw something at you? You wrote a paper, was it on measuring the predictive energy usage against the actual energy usage? And what salient points did you pull from that?
Well, that paper that I was showing was a retrofit scheme. F&G social houses, one bedroom, 40 metres squared, very small social houses, upgraded to what was supposed to be A2 standard. But what we found was that many of them were operating outside of that range, primarily B2, B3, and even SC1. I suppose the first thing is the problem with compliance modelling. These buildings they have PVs, they have a heat pump, they should be A1 by a compliance modelling assessment, but in truth, the retrofit was totally inappropriate, really. Every single one of these homes got its own heat pump, like 5 kilowatt heat pump. It's totally oversized for the small homes. Well, you could have serviced them all using, a couple of heat pumps. Yeah. There was a lot of issues about the heat loss through the wall. We still don't know, and it's often, and say the other paper I was showing was the in situ U values in NZ buildings. We go and measure it, but then it's, and we can show underperformance, but you can't do opening up works on newly retrofitted social homes. But so we're still trying to figure out why. Is like how is it that a blockwork concrete wall with an insulation product that has an EPD with a certain thermal resistance operates so poorly? Is it on-site issues on site? Is it thermal looping, air getting in behind it? Is it moisture build up in the insulation? Like these things, I think that we need to upskill across the whole construction sector so people know how to store insulation, how to install it, where the problems might occur, and act as a result.
Wouldn't it be great if we could actually reward design teams for designing buildings that perform better than, say, was a required baseline or something like that? I like to throw a grenade in every now and then. So to the panel, with the advent of AI being released into the public via ChatGPT and other AI applications, and looking into your crystal balls, how do you think AI might influence energy analysis and optimization?
Ian should take this one. Autodesk have to be all over this.
It's my turn anyway. We'll get to GPT in a minute, but I will say, we've been exploring it ourselves on a number of fronts, and some of you might be familiar with SpaceMaker, the conceptual planning tool that has a number of different kind of performance metrics in it, from things like acoustics to airflow, and one of the projects that we did internally, they've released as a beta, was an AI ML based energy simulation. And basically what we did was we used Revit and Insight, which already provides a pretty complete range. What we did was we created a training set for an AI based on a bunch of different building shapes and a bunch of different building locations with a bunch of different parameters. It was like quadrillions equivalent simulation runs, and then train the machine on that. And we now have an AI that you can basically place a block somewhere and get a real-time energy use intensity and move a few little parameters. And that's proved to be very, very accurate. You can validate it. And so we'll build it out more over time, but then there'll still be this need to do sort of explicit simulation, and we can sort of get to that. There's questions about accuracy and so on we can go back to. So that's a pretty solid use case of a very direct use case of it that, people can kind of understand. But then there's other things that we're doing around things like, taking models and or past drawings in and turning them into Revit models. There's things like, what information can you glean from a set of drawings, whether they be stupid things, like I say stupid, like annotations and stuff like that. How can you automate that kind of work and so on? So there's lots of interesting opportunities there. Relative to ChatGPT, I think there's definitely some sort of paradigm shift there. This is something that's significantly new and surprising to people that is going to change some things for people, right? Like, even down to writing an email. We were saying, we were using it there the other day to say, what are the top 10 requests for Revit from Revit Idea Station? Like, there's thousands of them in there. We're always looking at them, and you're trying to see the signal in the noise. And it did a pretty good job, like finding the sort of top requests. So there's lots of different ways we can use it. But I think it's such an early stage thing, and clearly some of the things that it's not always right. It still needs that expert to do it. But yeah, we are in an age where these kinds of things are possible, and we're only starting to learn and discover what we can do with them, and then what the sort of reaction to them will be. Like, how would a client feel if they felt that all of their specifications had been written by ChatGPT? Not sure they'd appreciate that too much. They're paying for a professional to look at it and so on. But it's definitely very fascinating. There's going to be all kinds of applications.
It's watch this space.
Absolutely watch this space, and there's more to come for sure. Yeah.
Okay. On your behalf, may I thank the 3 speakers and panelists here this evening. If you give them a round of applause, they well deserve it.